Okay, I've got here some expressions involving square roots, and they all simplify. In order to simplify them, I'm going to have to use the fact that the square root of a times the square root of b is the square root of ab. And in fact, I'm going to be starting with things like this, writing 28 as a multiplication, a number times itself, and the trick is to make one of those numbers a square number, because then one of these square roots will simplify. So square root of 28, I could write 28 is 2 times 14. That's not much good because neither is a square number. But I could write it as 4 times 7, so I have the square root of 4 times 7. This rule lets me write that as the square root of 4 times the square root of 7, but the square root of 4, because 4 is a square number, simplifies to just 2, and I leave the other one as root 7. That one doesn't simplify. So I've expressed root 28 in terms of a simpler square root. Similarly, root 48, well, I could write it as 4 times something, okay, but it's better if I recognise that it's 16 times 3. 16 being the biggest square number that I can use, so I can write it as the square root of 16 times the square root of 3, and the square root of 16 is 4, so it's 4 times the square root of 3. Now, what would have happened if I'd only realised that 4 is a square number that I can use here? Well, I can get to the same answer, but it'll be a slightly longer root. So let's just think how that would have worked out. I would have said the square root of 48 is the square root of 4 times, well, it's 12, makes 48. So that will give me the square root of 4 times the square root of 12, which is 2 times the square root of 12. But then I'd need to remember that 12 itself can be written as a multiplication of 4 times something. So carrying on, it's 2, that's this 2 here, and then the square root of 12 is the square root of 4 times 3. I need some more space. So I'm going to get 2, this 2 here, times the square root of 4 times the square root of 3. But the square root of 4 is just 2, so it's 2 times root 3. And 2 times 2 is 4, so I'm going to get to 4 root 3, as I did before, but it has been a longer root. So it's not absolutely essential to get the biggest square number that we can use, but it does help to keep the work short. Okay, and then for my last one, well, I've actually just done root 12, but let's write it out as we would. So this is the square root of 4 times 3. And 27, what square number can I divide 27 by? Well, the answer is 9, so it's 9 times 3. So the first one will simplify to root 4, root 3, and this one will simplify to root 9, root 3. And the square root of 4 is 2, so that's 2 times the square root of 3. And the square root of 9 is 3, so that's 3 times the square root of 3. And then what's rather nicely happened is I've got the square root of 3 times the number both times. So this is like having 2x plus 3x. I can combine these two terms because the surds match. So this is a grand total of 5 times the square root of 3, and I've simplified this addition. It just turns out this one can be done in terms of a single surd. Not every combination of adding will simplify like this. It just so turned out that because these root 3's matched, I could do it this way.